Have you admitted the participants?
I can't see the.
Leo?
Yeah, actually, I'm helping to admit all of them.
Yeah, admit all of them. Okay, thank you.
Yeah.
So I think they've been admitted. People.
Good morning, everyone.
Yes, hi.
Can you hear me?
Yes, I can. Marlene Reed here.
Morning, how are you?
I'm fine, thank you. What's your name?
Richard. My name is Richard.
Yes, I think I've met you before, once before when I lived in Kenya.
Okay, maybe.
Good morning.
Morning.
Good afternoon.
Good afternoon. It's morning for me.
Yeah, it's morning for me as well.
I'm logging in from Canada.
Yeah, and I'm logging in from England. Well, Ireland, actually.
Okay.
What time is it in Ireland?
It's 12:10, lunchtime.
Okay, and it's just 7:11 here. I'm so excited because it's the first time I'm actually sitting in a live meeting.
Okay, I think we are all in and we can start our talk today. So just a quick introduction. My name is Richard Kipngeno, the Birding and Membership Officer at Nature Kenya. And it's a great pleasure being with you today for our members talk. So talking about the birds of Arabuko-Sokoke Forest and agricultural areas around it, or rather the farmlands. So I will introduce today's speaker, who is Mr. Simon Musila from the National Museums of Kenya, who will take it off from there. Welcome, Simon. Thank you so much, Richard. I am Simon Musila. I work at Mammalogy Section, National Museums of Kenya. And today I'm going to present a talk on the birds of Arabuko-Sokoke Forest and agricultural areas around it. These are the farmlands. Welcome. The pictures are some of the species that are found there. So for introduction, birds belong to the order Chiroptera, or the flying mammals. And these are the second in terms of species richness. Rodents being the first one. We have more than 1,300 species of birds globally, more than 220 species in Africa, and more than 100 species in Kenya. So many people, when they hear of birds, they think that there are few species. Actually, there are many species. Birds are divided into two main subgroups. We have the Chiroptera. These are the fruit birds, which eat fruits and nectars, and constitute 30% of all the birds species. They use eyesight, and they also use their sense of smell, which is very well refined. They use their eyes. You can see that like this species, their eyes are very big and the ears are small. So they use their sense of eyesight and smell to find their way in nature. We have also the Microchiroptera. These are the invertebrate feeders, the insectivorous birds, which constitute 70% of all the birds. And these ones use echolocation to find their way, mainly use echolocation to find their way in nature. This is an example of insectivorous birds with small eyes and large ears. In terms of introduction, I continue. Birds are very important to the environment. For example, we have the birds are very important in terms of pollinating agents. We have more than 250 species that eat fruits and pollen. And because of that, they help pollinate many different plants which are found in the tropical forest and even the woodlands. And because of that, for example, we have these species, Rosetas egypticus, Epomophorus walbachi, and Eldon ovum, which pollinate they are known to pollinate the baobab trees, which are found in the drylands areas of Africa and Madagascar. Birds are also important in ecological pest control. This is important because they consume 60 to 80% of their body mass of arthropods per night. So this is huge amounts of invertebrates that they consume per night. And because of that, entropic protection by insectivorous birds is very important than even in birds in reducing the arthropod abundance and herbivory on agricultural plants. And some studies have been done in cotton industry in South Central Texas, US, and it has been shown that they constitute more than 741,000 US dollars per year in terms of the amount of pests that they remove from the agricultural areas. And birds are very important in terms of the seed dispersal. They are very abundant in tropical forests. And this is not obvious to many people because birds are active at night. And so they don't see that abundance because most of the time when the birds are abundant, they are active at night, we are actually asleep. This is also important for birds because of the fruit bats consume a lot of fruits per night, which is 50 to 50% of their body weight each night. Again, they actually move very far, like fruit bats can move 50 to 80 kilometers from their roosts. And so in these distances that they move seeds a lot from in far distances. So fruit bats therefore are useful in planting trees and in regeneration of tropical forests. Introduction, birds are also implicated in diseases. Birds are known reservoirs and sources of several microorganisms that can cause threaten zoonotic diseases. Zoonotic diseases, these are diseases which are transmitted from the wild to wild animals to human. And for example, we have 12 species of Eliza virus. These are viruses which cause rabies. This is a deadly disease which causes inflammation of the brain in both animals and people. And 11 of those Eliza viruses have been isolated from birds. So the main drivers of future emergence of bird zoonotic diseases, or the diseases which can be transmitted from wild animals to human, is agricultural expansion into forests and deforestation and urbanization. Because of that now, there's increase in the contact between people and birds, and this can increase a spread of zoonotic diseases. In terms of introduction, again, it is common knowledge that the remaining protected areas worldwide should have the original species that were confined to the pristine natural areas. These were the original areas, and most of the species which are easily threatened probably would remain in those protected areas. But is this perspective true for all biological species that occur in nature? When you look at agricultural areas around protected areas, are they of any value? Conservation of fauna is at protected areas. So for birds, the response of birds to species habitat quantification is not always very clear. The abundance of some species increase, and some others, the abundance may decrease, and even the abundance or even the species richness may be unaffected. So this is the basis of the study that I'm trying to present to you today. So this moves me to the two study sites where I was working, Arabuko-Sokoke Forest and the farmland. In 2013, I asked the question, the interior of Arabuko-Sokoke Forest and agricultural areas around it, which one has more bird species? So when you look at this map, the black line is the boundary of the forest with the surrounding areas. The surrounding areas around it, these are the farmlands.
So the question I was asking myself was, do we have more species in that forest, or do we have more species outside? And even the other question I was asking myself is the abundance of the number of individuals of the bird species. Are they more abundant in that forest or even outside in the agricultural areas? Arabuko-Sokoke is the largest coastal forest in Eastern Africa. And Eastern African coastal forests stretch all the way from Somali to Mozambique. And Arabuko-Sokoke Forest is the largest of those forests. This forest is an island. It's a big forest, but it's an island in the midst of agricultural areas and human settlement. So all the areas around this forest have been converted into agricultural areas and human settlement areas. Birds, okay, birds, plants, reptiles and amphibians and invertebrates and even mammal research has been undertaken in this forest to help justify the size of this forest and even conservation. But outside that forest, very little research is conducted outside that forest, because outside that forest or in the agricultural areas, there seems nothing or probably nothing of conservation value that the conservation NGOs or even the government should focus on. But my study wanted to even examine outside and check whether we have birds even outside there in those agricultural areas. So I did several studies. And one of the study that I did was to find out whether the diversity of birds in the forest and outside. Birds are very highly mobile animals and tend to traverse open areas and exploit partially distributed resources in the environment. So they can actually move inside the forest. They can even move out. So those birds which are inside the forest, inside the Arabuko-Sokoke Forest, at night they can come out. And those which are in the farmland, they can even move inside the forest because they really move a lot, birds. So I used mist nets, which are 3 meters above the ground, to capture birds in 81 different study sites in the forest. These are the red dots. You can see the red dots. These are the study sites inside the forest. Outside the forest, the green pyramids, these are the 81 study sites that the areas where I put the mist nets. Mist nets were 1 kilometer away from each other. And in each study location, I put 5 mist nets. And these mist nets were, in each study location, they were 100 meters from each other. I also did roost surveys where whenever a roost was located, I would survey by capturing birds inside those roosts. And then I would identify those birds. And then I would also estimate the number of birds found in each roost visually. So much of the studies outside the forest was done in the eastern part of this forest. These are the areas where you can see the green pyramid located, only in this eastern part of the forest, not the other parts. Results show that a total of 25 bird species were recorded, 19 in the forest and 25 in the farmland. So many species were found in the farmland than the forest. In terms of the diversity, the forest has a higher diversity, 1.48, than the farmland, which had 1.33. But the estimated number of bird species in the forest was lower because it was maximum of 25 species, 19 plus 19 plus 6. But the farmland had 31 species, which is 24 plus 7. So the estimated bird species richness in the farmlands was higher. In terms of similarity, how similar the birds communities were, using Maurice's similarity index, between the forest and the farmland, it was 65.8%. 18 species were commonly found in the two study sites. 14 roots were found, and this included 13 roots found in the farmland, and these were having 13 species, and only 1 root was found in the forest, and it was only used by 1 species. 10 bird species roosted in 7 limestone coral caves in the farmland, For example, there's this cave, Makuru cave, which had more than 1 million birds of 6 species. I have the graphs here of which were estimating the number of species found in each habitat. You can see the farmland one almost was reaching the asymptote, while in the forest it did not reach the maximum. Results in terms of abundance, 5,217 birds were captured, which included 82%, which is 4,327 in the farmland, and 19%, which is 890 individuals in the forest. In terms of the fruit bats, total fruit bats captured 733 fruit bats in the forest, and 3,397 in the farmland. And in terms of the species, the individuals of the insectivorous birds, with 157 in the forest and 930 in the farmland. So the most abundant fruit bird species were the rosettas and Pomophoras walbachi, and the numbers are provided there. The most common and the most abundant insectivorous bird species were the Cardiodama, which were 623, and out of these 621 were found in the farmland and only 2 in the forest. So the farmland had high species richness and abundance of birds than the forest. So the question would be why? Why would this situation be? Because it is expected that probably the forest would have more. So because of that, I had to continue doing more studies to find out why is this situation. One of the studies I did was to also study the activity of birds, insectivorous birds. Bird activity, the presence of an individual bird in nature, can be described as the movement of an individual bird out of its day's roost into the airspace at night to forage or commute to suitable feeding or drinking areas. So that is what I describe as bird activity. And this, for insectivorous birds, that activity can be documented directly with the mist nets, as I did, using the mist nets where I was using 81 sites in the forest and the farmland. You can also do that using the ultrasonic detectors. For insectivorous birds, can easily detect the presence of mist nets and avoid them. So, but when you use the detector, they provide a better method to monitor their presence in the wild. So that is the option I took. That even though I'd captured them using mist nets and the number showed that they were more in the farmland, I had to use the ultrasonic device to also see whether I would get the same results. So I used to monitor the activity of insectivorous birds. I did this in 69 stations in the forest and in the farmland using Patterson D240 ultrasonic device. And bird traffic, or the signals, which I'm calling bird passes. The pass is a signal of an echolocating bird that is picked by the detector. The picture here is the Peterson D240 detector, ultrasonic detector. So this is the one which I was using. And then it would pick a signal of an echolocating bird, which I'm calling a pass. And then it will translate it into a sound which is audible to the ear. So I would hear it and then count it. The detector was always tuned to or set to 33 kilohertz, 69 sampling station in the forest and the farmland. And the signals or the passes were counted using a tally counter for 10 minutes along 400 meters transect at the start of each hour. So then that detector setting of 33 kilohertz would detect the presence of 11 species of birds whose echolocation cores range between 25 and 41 kilowatts, and whose presence, these 11 species of birds had been captured in both in the farmland and in the forest during the mist netting studies. So the result shows that 14,727 passes or signals were counted, 10,552 in the farmland, and 4,172 in the forest. The mean number of passes counted per night in the farmland was 152, while in the forest it was 60. This graph shows the means, and those means was significantly different. There was a significant difference between those means. So in conclusion, insectivorous bird activity was higher in the farmland than in the forest. So again, the question arises, why is this situation when it is expected that here we have a natural forest, well conserved, and which is not destroyed, but now the activity of the insectivorous birds is also more in the farmland. This was not expected. So when you recap these results, they show that the insectivorous bird captures the farmland at 930, 157 in the forest. Fruit bird captures 3,307, 733 activity. So everything shows that the farmland was mainly where the main bird species were and the individuals were. So what the question which arises now is, what factors explain the differences in the assemblage of birds between the forest and the farmland? So one of the issue would be the distribution of bird roosts influence the abundance of birds in the farmland? Probably it won't. And for fruit birds, would it be due to the availability of fruiting trees in the farmland? For insectivorous birds, would it be due to the abundance of their invertebrate prey in the farmland? And then again, for both of the insectivorous birds and the fruit bird, would it be due to the preference to farmland habitat, which may be related to its habitat vegetation structure? So these are the factors that I was grappling with, and that which I also wanted to find out whether these are the things which would explain the differences in the abundance of birds in between the two habitats. So for birds, factor one, would distribution of birds' roost influence abundance of birds in the farmlands? Studies have shown that the availability of roost sites influence the distribution and abundance of birds. These are studies that have been done. But for my case, when I did the roost surveys, I found there were 14 roosts. 13 of them were in the farmland, and then one in the forest. This map shows the distribution from A to J. Only one roost, which is I, was found in the forest, and that one roost, which was found in the forest, Arabuko-Sokoke, there's just a few individuals, but while one cave in the farmland had more than 1 million birds. Actually, this cave B was having more than 5,000 individuals of fruit birds, rosetas and gyptiacus. So for example, another study has been done in Madagascar, and bird species richness is highest in dry region of Western Madagascar and humid East because of high density of limestone karst roost. So probably the abundance of the roosts in the farmland in the eastern part of this forest where I did my study would explain the distribution of the high distribution and abundance of birds in the farmland. So I did also another study where about insectivorous birds, invertebrate prey in the forest and the farmland. I wanted to, the primary food of insectivorous birds is in invertebrates, especially insects. The activity of insectivorous birds is influenced by the density of invertebrates as well as vegetation characteristics. So the question was, did the abundance, or is the abundance of the invertebrate prey in the forest and the nearby farmland does it influence the presence of insectivorous birds? So that is the essence of why the invertebrate prey study was done. So I used light traps, which have been extensively used to capture flying nocturnal insects. And then during this study, I used 4 solar-powered lights, which were operated for 4 hours each night in the forest and the farmland in 12 different study sites, in each 2 study sites. And this is the setup. This is the solar light that I was using. DB light, and this is the setup. We had a white cloth which was set up in an open area, and then down below it, I had a plastic sheet which was put there. And this picture shows the operation of that light trap at night, where the light was directed at the hang white sheet, and then flying insects would be attracted to that white cloth, and then they would strike it and fall on the plastic sheet, or even stick. They would stick there, and I would collect them. Collected moths were killed using chloroform paper in glass jar, and later preserved in plastic containers with toilet nappies. The other invertebrates were collected in plastic jars and stored in 70% ethanol, with samples of each for the forest and farmland kept separately. So the result shows that a total of 6,557 individuals and invertebrates were captured, which was 52% in the farmland and 48% in the forest. The farmland had the largest number of the flying insects, the menopterans, and coleopterans, the beetles, while the largest number of lepidopterans, these are the moths, and also bigger sizes occurred in the forest than the farmland. The mean number of invertebrates, and this bar graph shows the mean number of invertebrates captured in the farmland was larger, which is 260. You can see this 260. Then in the forest, 200. But there was no significant difference between the medians of captured invertebrates in both study sites. So the availability of prey, invertebrate prey, does not explain the differences in the insectivorous bird abundance in both study sites. Yeah, so the prey abundance does not explain why we have more insectivorous birds in the farmland, because it is the same. So I had to move on and try to find out what other factors explain this. So I also looked at the habitat structure in the forest and the farmland. The tropical forests provide vital resources such as fruits, pollen, and leaves to fruit birds, as well as a wide variety of invertebrates consumed by insectivorous birds. The levels of vegetation openness and thickness influence the selection of foraging sites by insectivorous birds and fruit birds. So the question I was asking, did the habitat structure and abundance of fruit trees resources in the forest, SF, and nearby farmland influence birds distribution in both study sites? So I used point-centered quarter, the PCQ method, to assess wood vegetation of plants in 210 points spaced at 310 spaced at 30 meters apart in each in the forest and the farmland. This is the setup of the PCQ point. And the feature shows that at each point, it is divided into 4 quadrants. You can see the red dots that show 4 quadrants which have been labeled there. So in each quadrant, I had to identify a tree which had more than 20 dBH. And then I would also identify the tree which is nearest to that point. The tree was more than 20 centimeter dBH because these are the trees which are likely to be used by birds. For example, if they want to roost, or potentially, these are bigger trees that potentially would have hollows that probably would be used by roosting birds. So in each quadrant, the tree nearest to the center of the point here was identified to genus or even species level, and then the distance to that tree was also estimated, and the dBH of that tree was also recorded, and also the crown diameter. So 4 trees were targeted from each PCQ point. So the idea was to know what type of trees are found in the forest and the farmland, and their potential in producing fruits that can be eaten by fruit bats when ripe, and also actually to document the data to document the habitat structure. So I documented the undergrowth or the understory vegetation cover. This is vegetation cover below 3 meters, at a maximum of 3 meters and below. So this was assessed by use of cover boards, which are generally squares of alternating colors, normally called checkerboard. The checkerboard I'm talking about is this. The one particularly I used is the one like this one, which is you can see here in this picture below, which are 25 squares, which were painted red and white. Mine are 25 squares. And the assessment was done in 210 PCQ points in each study site in the farmland and the forest. So all I did, counted the total number of squares covered by 50% vegetation matter from the center of each PCQ point in the north and southern direction. So for example, in this picture, we have only one square, which is covered by 50% of vegetation cover. And so this area is very open, and as I have very open understory, not cluttered. At this point, we have 21 squares which are obscured by vegetation, which are highly cluttered. So this area is very closed. So that is how the understory or the undergrowth cover was estimated. Results shows that for trees characteristic in the forest was dominated by 4 indigenous trees. These are Brachystegia speciformis. These are the Miombo woodland. And then we had Xenometra berry, 30%, each of them, followed by Manicara asperensis, and then Armenia pericosa, which is 11%. The total number of trees which produce fruits which could potentially be eaten by fruit bats in the forest were 166. I checked all the trees that I found in the forest from a publication by Becce, 1994, and I checked the type of fruits that they produced, and out of those I counted 166 trees which would produce fruits which potentially would be eaten by fruit bats when ripe, and some of the trees which include them are the Manicara asperensis, the Mimosops, the Linea, and the other one listed there. In the farmland, it was dominated by orchard of exotic fruit trees, which was coconut was 54%, mango 31%, cashew nut 11%, and neem 3%. The number of trees which produce fruits which are eaten by fruit bats in the farmland were 384, and this included the mangoes, the cashew nuts, the neem, and the guavas. So, for fruit bats, would it be due to the for fruit bats distribution? Would it be due to the availability of fruiting trees in the farmland? I think possibly this is a good reason, which explains why we have many individuals of fruit bats in the farmland, because I had 3,393, while in the forest I had 733, and so 46% of trees, 384 in the farmland, which include mangoes, cashew nuts, neem, guavas, they produce soft, very large edible fruits eaten by fruit bats. And these have been recorded by other authors. In my study, these are pictures of fruit. These are cashew nuts, which have been half eaten by the fruit bats. And this is also mango. Here is a picture which is not clear, but it's a Hemorrhage individual that was captured in the net carrying a fruit of cashew nut. So in the forest, I said 166 trees in the forest produce edible fruits which are potentially eaten by fruit bats. But these fruits are very small and are of small size, and probably they are avoided by bats. Studies have shown that the abundance of fruit bats in the environment is influenced by the distribution of fruiting plants. So the large number of fruiting trees in the farmland, especially mango, cashew nuts, and others, probably explain why we have large number of individuals. Is another factor that explains the presence of large individuals of captures of fruit bats in the farmland. In terms of habitat structure, the DPH of farmland trees was significantly larger. If you look in this table here, the DPH of farmland trees was 50.9, while in the forest it was 39.4. These are large trees in the farmland, and potentially they could be used as roosting trees by bats. Again, when you look at the understory or the undergrowth vegetation cover and even the ground cover, in the forest it was higher, meaning that the forest interior was more closed as compared to more open farmland. So this habitat structure would potentially constrain use of habitats, that particular habitat by birds. These are pictures of the forest. This is the forest. You can see, except the road that goes through it, how thick the forest vegetation is, while this is the farmland, one of the pictures of the farmland, how open it is. So for both the insectivorous birds and even the fruit bat, would it be due to the preference to farmland habitat, which may be related to its vegetation and structure? So when you look at the prey was the same in the two habitats, which is the farmland and the forest. And so we expected the same kind of use by insectivorous birds, which is not the case. So probably this could be related to the way the differences in the understory structure of the two habitats, the differences in understory structure of the two habitats. For example, the percentage understory cover or undergrowth in the forest was more closed than in the farmland, and this can inhibit birds' habitat use of that particular habitat. For example, the understory was in the forest was 38 point, the mean was 38.2, while in the farmland was 5.8. This is so the forest was 7 times thicker than the farmland, and this can constrain bird use. Research has been done, and it shows that more open habitats are more used by birds than overly closed habitats. There's an example of a species of bird that was captured. Many individuals of Nectaris thebaika. This is a clutter tolerant bird. The individuals of that particular species were captured in the farmland, and these are 40 individuals, as compared in the forest, only 14 were captured inside the forest. Vegetation thickness. Some research has shown that vegetation thickness or clutter or closeness can inhibit flight of some species, and also it can make prey location and capture more difficult. So even though the two habitats have nearly the same kind of insectivorous invertebrate prey, the two habitats are not being used in the same way, probably because in the forest it is difficult to locate the prey and even capture it, while in the farmland it's more open and birds can easily fly there and capture and forage there. Again, large birds, especially fruit birds, which with large wingspans are less maneuverable in thick habitats and forage in the open areas. So probably the fruit birds which have large wingspans and might find it difficult to maneuver their way in the forest habitat are finding it more easily to move and forage in the farmland habitat where they were being captured more. So in conclusion, and also a recommendation, although the farmland around the Arabuko-Sokoke was very disturbed, then the interior of Arabuko-Sokoke Forest, which is well conserved as indigenous trees, but still were actively using the farmland. And this probably underscores the need for more research for more bird research in African agroecosystems or agricultural areas, to be able to know what kind of species are found there and how often they're using these kind of habitats. So for recommendation, there's need to do more research on how birds are moving. There are more routes than which are found in the farmland, but it is not clear when birds emerge from those routes where they are going. It is also not clear whether those birds which were captured in the forest, whether they are coming out. So movement ecology of birds is needed by using maybe some radio transmitters and trying to see whether how birds are moving within these two habitats which are just nearby each other. In terms of conservation action, there are many trees which are found in the farmland, coconut trees, mangoes, and cashew nuts. And the local people depend on them by selling the fruits. But there's need to, for example, establish a good value chain that can increase the benefit the local people derive from these trees. And in that way, these trees, the value of these trees to the local people will be enhanced. And probably that would ensure that they will continue to protect those trees, manage them so well, so that now probably they can continue to maintain the habitat as it was when I was doing this study. And probably that kind of habitat is the one which is one way or another is sustaining the number of birds that I captured there. In terms of management and policy actions, there's need to develop a national policy to map, protect, and conserve birds, because birds' roots, because when protected areas were set aside in Kenya, roots were not considered. Not even roots, birds' distribution were not considered. But we know that many roots, like you have seen in my map, most of them were found outside the forest. And this is the same situation that occurs all over Kenya, and I think all over other places. And so there's a need to develop a national policy to actually map the roots. We know where they are, and also we protect them, and we conserve them. Again, there's need to develop a policy to enhance the farming of coconut, mango, and cashew nut trees along the Kenyan coast. The Kenyan coast is very long, more than 600 kilometers, all the way from Somali to Tanzania, and much of it actually has mango, cashew nuts, and coconut trees. And this kind of habitat provide the way my research has shown, provide a very nice habitat for birds. And so if the government can put more money, more research, more management options to this kind of habitat, probably outside the protected areas, we would maintain a natural habitat that would continue to provide a suitable habitat for birds that are found there. And those birds will continue to provide the ecosystem services that I talked about early at the beginning. Thank you very much. I would like to acknowledge support given by many people whom I've listed here, who have supported me in various ways. Thank you very much again for your time and attention. Thank you so much.
Thank you, Simon.
Thank you. Welcome.
It's nice to see you. I remember you coming to Friends of Fort Jesus.
Oh, really?
Yes, you came to give us a talk there.
Oh,
A long time ago. Yeah, I don't live in Mombasa any longer, but I like to keep in touch.
okay.
Okay. Now, my name is
Simon,
John.
can we ask some?
My name is John Kabue from the Mammal Committee, and I'm going to take you through, I'm going to moderate the question section. So I'll kindly request you, if you have any question, you put up your hand in the chats, or you type it in the chats. Then I'll be able to see it, and I'll give you the opportunity to ask the question. Any
Can I go? Can I go first? My name is Paul Webala. It's not a question; it's truly a comment. Can I?
Yes, yes.
Very generally, I think I want to acknowledge the fact that this is a very, very important study of birds along the Eastern African coast. It's not easy to study these animals; they're nocturnal. And Simon did a serious study at Arabuko-Sokoke Forest. And I want to acknowledge that he really would try to explain why the forest was poorer than the farmlands. So a few comments though, that today species of birds are over 1,400 species, not 1,300. And that we no longer classify birds under that dichotomy of Microchiroptera and Microptera. Now, because lots of Microptera are also related to, like Rhinolophidae, are related to mega birds. So we no longer classify birds in that two way. We actually look at families instead. Now, more fundamentally, farmlands were richer. Probably because, in my opinion, forests were richer than farmlands, mainly because of one reason: the methods that were employed. The captures, lots of insectivorous birds, like Simon rightly put it, are able to detect and avoid mist nets, except common species like Cardiodama that will easily be captured in mist nets. And those cave birds that Simon has been talking about will easily be captured in mist nets. However, there are lots of forest specialist species, forest Indian species that are not recorded in this study. And they easily, because of the type of echological codes they use and their wing morphology, easily detect mist nets and avoid them. Because of their wing morphology and because of the high frequency calls they use, they will easily avoid mist nets. But secondly, and also more importantly, is that the type of detector that Simon used was heterodyne. It means you can only listen to the calls. It was recording calls around 3 kilohertz. Lots of high frequency birds you cannot listen with them using that type of detector. So for example, hipposterids, high frequency calls for hipposterids cannot be detected by that type of detector. You can't listen to them using that detector. Therefore, those type of species and Crivola and lots of Aspergillionids, those type of species were not either captured or recorded by that type of detector. And therefore, there's a complete underestimate of those species in the forest. When you look at roosts that Simon is talking about, Simon was looking at caves, but there are other roots as well in the forest. We're looking at hollows. Those were not counted. We're looking at foliage. Those were not counted. So the forest, in terms of also roots, is richer if you don't look at caves alone. So my understanding is that if time expansion type of part detectors, acoustic devices were used other than TX240, there were a lot of species that would have been recorded and are missed in this study because of the type of equipment that was used plus captures. Thirdly, fruit bats, given their wing morphology, and Simon rightly, you put that in your conclusions, because of the wing morphology will not fly in dense vegetation, and therefore you'll find them in outside the forest. They are easily captured in mist nets. So, and because of that, they will inflate the abundance index. They will inflate the number of captures outside. They will mask other species because they are captured in large numbers in mist nets. Plus the common species generalists like Cardiodama and those that are found in caves will be captured in mist nets. And so you'll think that the farmlands are richer, but actually what is being recorded in farmlands are common species, generalists, plus fruit bats. The specialist species, forest and deer species that fly in clutter, that fly in dense vegetation, are highly maneuverable and will easily avoid misnets and will not be recorded around 33 kilohertz using a DX240 kilo DPAR detector were missed. So the forest still, in my opinion, is richer, and this should be discussed as well in terms of the methodology to use it. All other factors have that structure being discussed there had an influence, and that had an influence in terms of flight morphology of bats, and therefore the forest, in my opinion, is richer than farmlands. If complementary methods were used, not just captures and that DX that uses hydrodyne method of recording calls were used, including hub traps. There are other methods called hub traps that will capture high frequency bat calls. Bats are using high frequency calls will be captured in hub traps and not misnets. And therefore that should be discussed. And I repeat, I think the forests are richer than the farmlands because the farmlands are having common general species that are flying from caves and are easily captured. Thank you.
Thank you, Daktari. That was very informative. That was very educative. I don't know, Simon, do you have anything to add on that? Or
yeah, I would like to thank Dr. Paul. He's actually my mentor, and he's doing the right thing. The things he has pointed out, actually, it is right what he's saying, and because this is just the beginning. This is the first study on bats that has been done in the forest and also the outside. And he has pointed out a lot of limitations in terms of the methods I was using, and that is correct. And this, as I said, this is the beginning. And so it shows that there's still a lot of work that can be done in these two study sites. There's a lot that can be discovered in these two study sites. And this is just the icebreaker. My study kind of is the icebreaker. And I'm sure there is much that will be found as we continue to do more research, trying to sort out the weaknesses of my study and trying to understand more about the species and their distribution. Yeah, thank you so much, Dr. Paul.
Ante, there is another question here from Caroline Joki.
Yes.
Yes. How do the locals perceive bats?
Okay, yeah, good question. I did, there's a study I did in the same area, which I've not reported here, the bats-human interaction, where I interviewed 394 people living around the forest. Most of them, the perception or the attitude towards bats was negative. People thought bats were used by witches, witches to cast spell on them. So in general, the bats were not perceived positively. There was negative attitudes by both males and females. Again, there was also a positive thing about it. The locals said that bats were very useful in dispersing seeds, especially the seeds of cashew nuts, because they were moving. They would. What happens is that fruit bats grab a cashew nut and then they move it from the parent tree to a feeding patch. So in that way, after they feed on the soft part of the fruit, the seed will fall down. And this seed is collected by local children in the morning. They can roast it and eat it. Or if it's a lot, they can actually accumulate them and they sell. So they said one of the important benefit of bats to them was that it was useful in dispersing cashew nut seeds. So that was good. That was good. But generally, the attitude was negative, as it should be, as it has been recorded in many other places anyway.
Asante for that, Simon. There is another one here from Michael.
Yes.
So the bird sampling in the forest, was this done in the understory or in the canopy?
Yeah. This was done in the understory. This is, I said that I was using mist nets, which were maximum height of 3 meters. So this was in the undergrowth. So, and Dr. Paul talked about this, where he was saying that it is good to also use canopy nets and even use hub traps. These are other kinds of methods of capturing birds. And so the canopy, which is anything above 3 meters, that kind of habitat was not surveyed. And so that is why I said that there's still more that needs to be done to know more about the birds of that forest. So canopy was not done.
That was a very good question, I think, because again, this is Paul Webala, because if we don't use complementary sets of methods, then we miss out high flyers. And Simon had just mentioned that certain methods have certain limitations. So if you really want to do a complementary, and Simon was there for a long time, it is a comprehensive study. It requires a lot of effort. If you don't use complementary efforts, then you risk underestimating species presence in those areas. And so canopy nets are also very expensive. And like Simon says, it requires a lot of resources to have all sorts of equipment. So, and that's partly why the forest is showing that it's poorer than farmlands.
Asante, thank you. There is another question here for you, Simon. Is there a different flight behavior in the forest compared? Is there a different flight behavior in the forest compared? That question is from Stephen.
Okay, the flight behavior. I'm not sure what the question refers to. Flight behavior. Okay, because I was only involved in like using mist nets to capture birds, and also using the detector to record the presence of the birds. In terms of flight behavior, I think I did not do much about that. And that is why at the end of my talk, I was recommending probably we could have movement ecology where we would have some transmitters and put on the birds, some birds, and then we would be able to know how they are moving from one place to another. So
Can I help you? Can I help you there?
Yeah, help me.
Yeah, you are right by saying more studies are required to do movement ecology and look at the wing morphology of different species. Yes, but the truth is also that different species have different wing shapes and aspect ratios. So because of that, some will not fly in the open, some will fly in dense vegetation. So flight behavior for a species that is flying, a general species that will fly in the open and fly in the forest, the flight behavior will be different. And even the collocation calls will be different depending on where they are flying. However, some species, because of their wing morphology, will not fly in the open. They will fly in dense vegetation. They are highly maneuverable. For those that have narrow wings, like free-tailed birds, chirophones, and what have you, have very narrow wings. They can't fly in dense vegetation. They fly in a straight line. They use low frequencies. And so flight behavior is different depending on which species you're looking at. But for species that are using different habitats, it also changes where they're flying.
Thank you. Thank you so much, Dr. Paul.
Asante sana, Daktari. Thank you for that. I think we can move to the next question. This question is from Lenguya. He asks, the recent fire in Arabuko-Sokoke Forest, what was its effect on fruiting trees and the cascading effects to birds of Arabuko? Just a comment.
Okay, thank you so much, Lenguya. I'm not sure about how big the size of the area that was destroyed by the fire. And I'm not also sure about the type of vegetation type where this fire was found, because the Arabuko-Sokoke has 3 main vegetation types, which is the Brachystegia, the Cyanometra, and the mixed forest. In terms of my study, many individuals of birds were recorded in the mixed forest, but most species were found in cyanometra. So to respond to this question is that I'm not aware about in the particular habitat vegetation type where this fire occurred. It is not possible for me to know the effect of it, because the potential fruiting trees that I talked about, 166, those ones were recorded in the mixed forest. So potentially, if that fire covered a large area in the mixed forest, probably it will burn many individuals of those trees. But if it occurred elsewhere, probably it might not affect those fruiting trees. Yes, so that is my reply on that.
Thank you, asante sana for that. There is another question here from Zarek. How easily accessible are the limestone caves to the general public?
These caves, the limestone caves, are easily accessible because we were actually locating them by getting information from the local people, and the local people would actually take us to those caves. So actually, they are easily accessible to the general public if you ask the right people. The people who know them, and I would caution this. It's good also to be taken by the people who know where they are and who can also guide you properly about those caves. So generally, they are there. They are available. They can be accessed. Some of them people have to pay to get to go in, because all these caves, these limestone caves, they are in private land, and the owners would charge you to get into them. But when you get into them, you also need to be guided properly on what to do inside those caves, so that you don't affect the birds which are found in the caves, and also for your own safety. So yeah, they're accessible. You need to pay the owners. You need also to be guided properly. Yeah, that is the situation about this case.
Can I just add something, Simon? Can I just add something before somebody says something else?
Okay. Yeah.
Payment is unnecessary. I don't want to say unnecessary evil. However, it's very important that we pay something to go to those caves, because that is the only way we can leverage their conservation so that they remain there. So we pay something small to the communities. Whether Simon goes there or I go there or somebody else go there, there's a standard fee that they charge people who are visiting those caves. They are very rich in abundance of birds. One of them that Simon mentioned, called Makuruhu, has 6 species of millions of birds. And so it's very, very important that we advocate and we support their conservation. And so we encourage that anybody who is going there must pay something to the local community, aside from also paying the guides. The guides there will take you there. So they're very accessible to reach to the caves, but then don't go there and then refuse to pay something to the community, because without them, those caves won't be there. Those areas are surrounded by farms, and in other areas, people have closed the caves amid fears of COVID-19 and so on. And so giving something small to the community helps us conserve those caves.
Okay, asante for that, Daktari. So there is another question here from Michael. Bat houses are increasingly used by people wanting to encourage insectivorous bats. Have this been used anywhere near Arabuko or in Kenya?
Okay, good question from my population. This is a good question. Bat houses, these are artificial kind of boxes that are constructed using the timber, and they are put up in the environment outside the houses, or even some of them are attached to the outside of the houses, and they are constructed using the required instructions or guidelines which have been produced by Bird Conservation International and others. Bird houses or boxes were first used in the US many years ago. But in Africa, South Africa have used bird houses. In Kenya, especially the question which is asking whether they have been used near Arabuko-Sokoke Forest. I'm not aware whether they have been used. Anybody has tried to put them there. But myself and my colleague, Dr. Paul, we're trying to work on a project where we can construct some and put them in different places. And so, but for Arabuko-Sokoke, they have not been put up. And so, but it's a potential place given the number of birds that are found, especially outside the forest. Probably it's a good thing if they can be put up, and also to test whether some of them can be used, because given that a lot of individuals of birds are being found outside, and we know with the increasing human population increase, much of that kind of natural habitat, the kind of habitat that is found outside the forest might be lost in the future. So probably bird houses might be the only rescue for these birds. So anybody who can try to put them there, we would actually start to see whether birds are able to use them. Not even in Arabuko-Sokoke particularly, but anywhere along the Kenyan coast. It will be a good project and it will be very useful. Yeah, so that is my reply on that.
Thank you. There is another one from Stephen. I'm not sure what this word means compared to the farmland. I'm not so sure what the question is here. But I think, Stephen, you can retake the question again. We will find time. So there is a question also from Leo. Before insights from Professor Webala, I was almost wondering what the implications of this study would be if at all we had more birds in the farmlands compared to forests. I think it is more of a comment. Would you want to add anything, Simon?
Yeah, you see, as I said, this is the beginning, Leo, this is the beginning of this study. And many of the people have heard about my results. They have always asked me the question, so you mean the forest should be destroyed? So, but I've always told them, I don't mean these results should mean that the forest should be destroyed. What it means that these two habitats, they are important for bird conservation. And so actually they complement each other. Yeah. And because we don't know the birds which are found in the farmland, whether they are going in the forest, or whether the birds which are found in the forest, whether they are also going out. That is why this is just the beginning of science, bird science research in this study area. And probably when we go there in the future with the best method, we may find the same results, or we may find different results. And that is why these kind of talks are also supposed to encourage people to come out and do more, and we found out more and answer questions which also linger from my study and from this kind of presentation.
Thanks, Simon. Paul, again, I just want to emphasize that both habitats are important because they support different species. And you can see from Simon's, he didn't provide a list, but you can see from the list, there are species that were exclusively recorded in the forests and others were exclusively recorded in the farmlands. So both habitats are important, and for the sake of conservation, and Simon's recommendations were very, very, very good, that we conserve farmlands and the forests as well. So it's very important that we conserve both forests, both habitats, the forests and the farmlands. The farmlands are very rich, like Simon showed, with lots of species that are roosting in caves and common species. That's very important for those species to be conserved. If you go to the south coasts, you'll find species that are very rare, called Gliotis passivali. They're only found in one cave. It's on farmlands. And so farmlands are equally important as the forests.
Thank you. Thank you, Daktari. Asante sana. There is another question here from Margaret. Do you think birds are perceived more negatively since COVID-19?
I would think so, since the outbreak of COVID in the world, I have seen people sending us links to asking questions about what we think about COVID and bats. And people have been trying to also investigate this kind of question. I haven't seen some papers, but given that bats have always been perceived negatively, even before COVID-19 outbreak globally, I would probably expect that they have been, the negative perception has increased with the new disease. Even though we know that bats are not the source of COVID-19, but because of that misinformation, people continue to perceive bats negatively because a lot of negative information is always given about them. So yeah, I would say so, yes, but not because bats are the source of the corona.
Simon, I can add something else as well here. That
Sure.
There are lots of reports, not in Kenya, that bats are being killed in Rwanda, for example, in Peru, in China, and we did a paper on that. That bats are being persecuted because of misplaced fear that they are causing COVID-19. They're the source of COVID-19. So there's a lot of ignorance out there about bats as a source of COVID-19. Here, the truth is that coronaviruses are many all over the places. Hundreds of coronaviruses in different animals, and most coronaviruses are harmless. The main problem is actually as human beings, and Simon talked about this earlier, that we're encroaching on wildlife habitats. We are trading in animal products. We are transporting animal products across the world. And the viruses that are circulating in animals, not just birds, are getting closer to us. We are getting close into contact by encroaching the habitats, by eating by eating them, like in West Africa, Central Africa, providing chances for spillover events. And when the viruses spill over, harmless viruses on the animals, when they spill over to us, they mutate and become virulent and become dangerous. And so the species to blame for the COVID-19 and other zoonotic diseases are us, Homo sapiens, and not the animals. Because we've destroyed their habitats, we've made them come into public spaces in urban areas and then closer to us, so that viruses are able to spill over, pathogens are able to spill over to us. And when they spill over to us, we have no mechanism of resisting them. And some of them mutate and become pathogens and become dangerous.
Thank you.
Thank you.
I see time is really going, and we need to finish up. And I think so we will just take the few remaining questions, and I think that will be it. So there is another, I think this is a comment from Zarek. Thanks very much. I'm happy to pay and recognize the conservation value of paying. That's a nice comment. Then there is this comment from Richard. Thank you for this insightful, interactive, and informative presentation from the Mammal Committee. It is our honor and pleasure to always bring you such talks to you. We welcome you to another insightful talk on Friday, 25th June 2021 on reptiles and amphibians, identification by Steve Spose. More details will follow soon. Then there's a comment from Margaret. So we need to educate people to be better stewards of our resources. Thanks for your insights. I think this is another announcement by Richard. Wednesday bird walks are on. We meet every Wednesday at the open space and front of the entrance to the museum gallery at 8. Sunday Birdwatch will be on 20th June 2021 at Ngong Road Forest Sanctuary. We meet at the Sanctuary main gate at 8:30 a.m. So I think I'll conclude with that. So you are very welcome to the Mammal Committee. This is what we do. We take pleasure in advancing the plight of mammals and in their conservation. So I think I will invite Leo, who is the chairman of the Mammal Committee, to give a small vote of thanks. Then he later invite Richard, and then we will close. Okay. Before we finish, there is a question. There is somebody who, Benjamin Kinyili. You can do it real fast, real quick.
Oh, thank you very much. Thank you very much for the wonderful presentation. My name is Benjamin Kinyili. My question was actually on Malbec virus diseases, which has been noticed in Mount Elgon being spread by the bats. And also there was a time it had affected quite a number of cases in our neighboring country, that is Uganda. Can you say something about that Malbec hemorrhage fever? Which actually is quite dangerous, and it might affect, and also it might mutate. Thank you very much.
Thank you so much.
Simon, let me add that because
okay.
very quickly though.
Yeah.
That Malbec virus was isolated in 1981 from a single Rosetta aegyptiacus bat at Kitum Cave in Mount Elgon, 1981. In Uganda, they found Malbec virus in a cave near Queen Elizabeth National Park in bats. But then, whether those bats, that Malbec virus, which is hemolytic, you bleed a lot, spilled over to humans in Uganda is another question. In Mount Elgon, indeed, a cave person who went there and handled the bat died of Malbec virus, but that was 1981. So it doesn't really mutate; it just spills over. It's been found in Rosetta aegyptiacus bats, not other species of bats, but also only in Kenya, one case, one bat at Mount Elgon of somebody who was in Kitum Cave at Mount Elgon National Park. So if you're not going to handling bats, basically because that guy was handling it, if you're not handling bats and you're not bitten and we take precautions in handling bats, chances of virus spilling over to humans are very rare. In West Africa, people eat bats, fruit bats especially, including rosettas and Edel and Helvum that Simon mentioned earlier. So we discourage people from bushmeat. And not just bats as well, even other animals eating meat that is not tested or inspected by the Ministry of Health officials. If that animal is sick from anthrax or brucellosis, that disease will of course infect you. So animals have pathogens. And because of that, we should be careful on encroaching on their habitats, but also on handling them, unless you're an expert or you've vaccinated against rabies, like Simon was talking about earlier. So unless you're vaccinated against rabies, don't just go out there and handle bats. Call on experts to do it. So unless you handle the animals, chances of being virus spilling over are very, very rare. In fact, very rare, 1%. And very importantly is that rabies is 1% from bats than carnivores, including our pets. So the point is that unless we get in contact with animals, including on their habitats, people are being killed today more from malaria. We don't complain about mosquitoes, do we? We don't. But more deaths are happening more from malaria than from wild animals. And unless we handle them, and in most cases because of population growth, we encroach on the habitats, chances of zoonotic diseases spilling over to humans are very, very rare. Thank you.
Thank you. I think Leo can take it from there.
All right.
I'm just on the Zoom meeting, yes.
How do we do this?
Okay, I think okay, maybe I'll just go quick. I think we can't hear you, Odile, if that is pronounced well. Maybe just to conclude, because we are short of time, I just want to thank everyone for showing up for this incredible talk. And I want to thank Simon Musila for the great insights into bats. And it has been really a lovely conversation, getting to hear from everyone else. So thank you so much for showing up, and we encourage you to be part of these mammal talks. And above all, we have a mammal application that we are asking everyone else to download. Just go to Play Store, try to get the Mammal app on your phone, and help us to map mammals in Kenya wherever you go. So we will really appreciate you downloading the Mammal app into your phone. And then it's my pleasure to welcome Richard to make the final remarks as we conclude. Thanks.
Leo, and thank you very much each and everyone who have made to attend our today's insightful talk. Thank you also to the speaker, Simon Musila, for taking us through nicely. Just a few announcements to make. Is that our Wednesday bird walks have resumed, and for this month of June, we are doing it at the museums, the Nairobi Museum Ground and Michuki Memorial Park. We are meeting every Wednesday at 8 a.m. Our Sunday bird watch will be at Ngong Road Forest Sanctuary, that's on 20th June. And we also encourage new members, also bring us some more members so that we work together the conservation journey. On 25th of June, we are having another talk about the reptiles and amphibians identification that will be presented by Stephen Sprouls. Otherwise, thank you very much and have a good evening.
Thank you. Bye-bye.
Bye, see you.
Bye-bye.
Bye-bye.
Bye. You can now leave at your own pleasure.
Bye-bye.